Is my screen visible? Everything's fine, right? Are you able to hear me? And the screen is visible, right?
Yes, sir.
Okay. So we are going to start with the logarithm function today. Hmm. Yeah. So you already have read about the exponential function, right? I guess in the previous sessions and all, you have already read about this function y equals to, or maybe fx e to the power x, correct? Where a is greater than 0, where a is greater than 0 or a is equals to, not equals to 1, right? So this function, when you were reading, right, this exponential function, then you would have known that this is a 1 1 function, right? Correct?
Yes, sir.
This you have already read about, right? Okay. So the logarithm function that we are reading right today is nothing but the inverse function of the exponential one. Okay. So this is nothing the logarithm function from now onwards, whatever we'll be reading, and then while plotting also. So when you will plot the exponential function, see what is the exponent? If you'll just plot it, this is how you plot, right? This is how it goes. X where a is greater than 0, or you can just say that a is greater than 1, because from 0 to 1 the function, the way you represent it goes up different, right? It goes something like a bit different. Okay, so it is a to the power x, or you can say 3 to the power x. A can be any value that is greater than 1. So this is how you represent, and you already know that so for any function that is inverse for any other function, so for this function, okay, so you have read about the inverse as of now. I feel like you have already read in the previous session, right? So about the inverse function, so for any function that is inverse, right? For a to the power x, we are saying logarithm function is the inverse. So how will you plot that logarithm function for any function that is the inverse, right? For any other function, how do you plot it? If you know the plot or the graph of a to the power x, how will you plot the graph of the inverse of a to the power x?
Sir, that will be the reflection along y equal to x-axis.
Correct.
Symmetric across y is equal to x.
Yeah, so it will go something like that, right? So this plot is nothing but the inverse, right? This is nothing but inverse of e to the power x. Okay, and
So,
that is what this is, a log function also. So log of x base a. So I'll just tell you. So this is how you, generally the plot you can get it very simply, because you already know the plot for e to the power x. Okay, the exponential function, if you know, and that you can plot it for the function wherever the a is from 0 to 1 also, and the same will get reflected for logarithm x base a, where a is from 0 to 1 also. But we'll start, I'll just give you a brief idea about the logarithm function, how do you represent and all. Okay, so you were having a to the power x. Yeah, so the logarithm function, the way you represent is, generally you call it as a log of x base a, right? So this a, okay, that you call it as a base, and there are some condition that you apply on a. Okay, so so this function is the logarithm function, and this function is nothing but the inverse of the function that you were reading. So this is a inverse of exponential function, and you already know that when you were reading the inverse, right? So any function, let's for example you have some function, and then you are getting the inverse of that. So you already know that here whatever you have the domain, that will become the what will, that will become the range for
Okay.
that inverse function, correct?
Yes, sir. Yes.
And
Correct.
whatever the range you have here, that becomes the domain for this function, correct? So same will be applicable for your exponential and logarithm function also. Okay, now for let's for example you have a function fx equals to e to the power x. Okay, and the condition a is greater than 0 and a is not equals to 1. So now for a function, right, for any function logarithm x base a, right, now what will be the domain here?
Real
Would
line.
be the real.
Okay, real line. Okay, so the again, so the here the domain will, sorry, so here the range will become what?
Real.
Real.
Correct. Now again here, what is the range here?
0 to
To infinity.
infinity.
0 to infinity. 0 should be included or not?
No, sir.
No. No.
So here the domain will become 0 to
Zero.
infinity. Correct. So now we can see that from the plot also. Let's plot it out. Okay, so we were plotting it. Okay, this is y equals to e to the power x, and this is y equals to logarithm of x base a. Now here I told you already a is greater than 1. Okay, because from a equals to 0 to 1, the plot I'll go through that also. But first I'll just go through exponential function where a is greater than 1. Okay, so now you can see that we were saying something, right, regarding domain. Domain are all those values where this function will be defined, right? So x you can put, so what are the values of x generally for a domain? So x can be from any L, right, from infinite minus infinite to infinite, right? So domain is nothing but all the elements, right? And you can see from here also, range is what? Range is the value of y, right? So for this function, y can be anything, right?
Sorry to interrupt. Can you fix your mic, please? There is a like sometimes your sound seems to be like buzzing and sometimes it's clear.
Is it for everyone?
Yes, sir. Sometimes it gets low.
Yes.
This okay. Please let me know if you find it again. Is it fine now?
Yes, sir.
Yes.
Okay. So what I was saying is the exponential function and the logarithm function are inverse to each other. Okay, both are one function, and now you can see that. And I was saying that you have already read about for any function for fx, whatever the domain that you have got it for function fx, the inverse will have the same as a range. Okay, and that we can see it from here. We plotted exponential function y equals to a to the power x, right? And then for that function, you can see that the domain, the values of x that you can put is from minus infinite to infinite. So that becomes a domain for this function. And similarly you can see that for a logarithm function the range is what? The y value. You can see that you can have any value of y, right, from minus infinite to infinite, right? So that's why the range here becomes r. Okay, for a logarithm function. Now for a exponential function, if you will just consider the range, you can see that the y you can get it from 0 to infinite only, right? You can just get it from 0 to infinite. Okay, and 0 also, till minus infinite, you'll be getting 0 you'll not be getting exact, but yeah, you can just think of as the range that you'll be getting from 0 to infinite, right? So infinite from here, and then yeah, 0 will not be coming. So that's how the range becomes 0 to infinite, and that is what you can see it from here also. So you will not be able to put 0 because at 0 the function will not be defined, and then you can put any value till infinite, and then the logarithm function will give you some unique value, correct? So that's how here the domain becomes what? 0 to infinite. Okay, so you can just interrelate both, and that happens for any function that has a inverse, right? I hope this is clear to everyone.
Yes.
Yes, sir.
Okay. Okay. So now we'll learning about some of the limitation that the logarithm function has. See, logarithm function na, is like for example, I was saying logarithm of x base a, right? A generally you call it as a base, right? And x is that value for which you are calculating logarithm. Okay, so any function, so any function that you are applying, right, the nature of the function will not change. So logarithm are generally use it because, let's say example, you are just measuring some sort of a distance, right? And then for a distance, that x value was coming out to be very large. So right, when you are apply that logarithm on that x, right, the value is will be having a sudden change in the value, and that will diminish. So the logarithm of that x value will diminish if x that you are taking as a positive value, right? And then x was, it was basically used it, I was just saying you how why it came into use and how generally it came. So there's some big value that was coming, so maybe the distance was calculated in starting from moon to sun or something, right? So the values that was coming out to be very big, right? So to reduce those value, right, we started using log, and then you will apply that big value, right? Let's for example, you have to write it 1000, right? And then you have to write 10k, and then you have to write 10 to the power 4, okay, something like that. Okay, so this two you have to write it. So writing this 1000 and 10,000 is a bit big number. I'm just talking about if it goes beyond some 10 to the power 16, 15, something like that. And then if you will start taking log of this, right, at base 10, then the values reduce, right? This will be 3, and then the value for this will become 4, right? So the value decreases a bit, but the nature doesn't changes. Nature, I mean to say, after 10,000, the 10,000 was coming, right? So here also, even though you'll apply logarithm, after 3 the 4 will come, right? So the nature, like if the function x, the value you are increasing, so log of x also will keep on increasing, so the nature of the function will not change if you are applying logarithm of an increasing function, right? So if we'll just apply a logarithm on an increasing function, the logarithm of that increasing function will also be increasing. May the rate, uh, when the rate will not change, well, only the value will change, okay, will start diminishing. So when in the coming sessions and all, not in many of the courses, you will see that you'll be learning about a lot of stuff, right, where you will start using logarithm just because you are getting the benefit that you are able to, because the x nature, any function, okay, on which you have to work it, and then fx you are not able to. So what you can do is you can just maximization function is the one function where generally we use the logarithm, okay, and that helps a lot, okay, in ml and all, where you can start using the logarithm, okay, and the function was increasing or decreasing. Even though you apply logarithm, the nature of the function, the whole function will not change. If fx was increasing, the log of fx will also be increasing, okay. So I was just trying to say you, if you have something like 10 or 10k, okay, if you'll apply log here and if you'll apply log here, right, so the only the value will decrease. But if you'll have to compare it, if x was greater than y, right, so if you'll apply log x and log y also, so x will, log x will be greater than log y, okay. Only base you have to check whether the base was greater than 1 or not, so that I'll come upon, okay. But as of now, the basic things, what I was trying to say is the function's nature will not change even though you apply log function or not, okay. Is this
Okay, sir.
clear?
Yes, sir, it is clear.
Okay. Yeah. So on the some limitation that I was trying to say on log function was, let's say example, you're writing log a, log x base a, okay. This is the function that you are writing, okay. So the one thing is x should be greater than 0, okay, that's the one condition. The second condition, why x is greater than 0?
Because that is the domain.
Correct, that's the domain, yeah. When we were discussing about the log function, right, so this we said, right, the logarithm function, this is how you represent the log function, right? And then so you can see that the domain, to x value, that you can put it from 0 to infinite, right? So that's how the first function came. And the second thing is the a should be greater than 0, so the base can't be negative. Okay. And the
Yes.
third thing is this a can't be equals to 1. Okay, that was happening for your exponential function also. A can't be equals to 1, otherwise it will always be coming out to be 1 to the power infinite, and 1 to the power x, whatever you value put, you will get always a constant function, right? So this three should be there in your mind. Okay, whenever you're writing logarithm function, right? So this x should be greater than 0 because of the domain, and then x should also be greater than 0, and then should not be equals to 1. I hope this is clear. And then yeah, x though I already kept it as x greater than 0, so you can't consider x as 0 also. So this feature will help you whenever you'll be asked to calculate the domain of any function, domain of any function that is given in the form of a log. Okay, so these three features should be there in your mind. Okay, so this was there. Next example, I'm just giving you something. So solve, and if you have to calculate the domain for a function, right? Let's for example, the function is log of 1 plus x, 1 minus x, and then base 3. Okay, what will be the domain for this function?
X should not be 1 and x should be greater than -1.
Okay, so simple thing is, whatever is this, you consider the whole thing, you consider it as a x, right? This is what you can just think of as log of capital X cube 3, right? Base 3. I already told you, if a function is represented like this, right? X is always greater than 0. So here the capital X is what? Capital X is 1 plus x minus upon 1 minus x, right? So this should be greater than 0. Correct? One condition, and the other condition is what? This denominator can't be 0, right?
Yes, sir.
Okay. So this 1 minus x should not be equals to 0. So x should not be equals to 1. That is clear from the first condition. And then the second thing is what? See, the other condition has been satisfied. A is greater than 0, A is not equals to 1, because you can see that A is greater than 0 and A is not equals to 1. Okay, so you just have to check for the first case condition, right? And then if you are getting something like that, right? What will be the value? This is your -1 and this is your +1, right? And then if you put any value that is lesser than -1, what will happen? Let's for example, you are putting -2 here in this function. What will happen?
Will get negative.
1, correct. 1 minus 2, and then 1 of -2, right? Yeah, correct. So this will not be coming out, right, in our solution. So from minus infinite to -1, this will not come, right, in our solution, because if you'll just put any value that is lesser than -1, that doesn't satisfy. Correct. Now take any value from -1 to 1. Take 0. If you will take 0, what will happen?
Satisfies this condition
It will
greater than
satisfy,
0.
right? Correct. So this satisfied. If you take any value that is greater than 1,
Same, sir. It
it
will
Again,
doesn't
zero.
satisfy.
satisfy, right? So this also will not come. So the function goes something like that. So this
Okay.
is the area, right, where the function satisfy. That means that what is the domain? X belongs to -1 to 1. Correct. And we already have considered this, right? Mine 1 can't be there in the answer, right? So that's why we can. Fine. Is it fine to everyone?
Yes, sir.
Yes, sir.
Yeah. So let's, for example, if you have a function logarithm of 4 1 minus x. What is the domain for this function? This, consider this as a capital X, right? So 1 minus x should be greater than 0. Okay. What will happen? So that means x is less than 1, right? So
But
from
in the
minus
previous question, your numerator, sorry, your denominator was should be like x shouldn't be equal to 1. So shouldn't we like ignoring 1 in the region? Because if we take 1, then the denominator becomes 0 and the function is not defined.
So we are not considering, no? This is open bracket, right? This is
Okay.
open, right?
But in the figure you drawed, shouldn't it be like slightly,
Which figure?
neglecting the diagram that you drawn?
This one, huh?
Hmm. Yes.
This one. Okay. So one condition also. See, one thing here it is greater than zero, right? So if it, this
Mhm.
was greater than equals to zero, then I would have considered, I would have taken minus one and one also. Here it was zero, right? Here it's just greater than. Okay, the equality doesn't hold here, right? So if the equality doesn't hold, whenever you are solving with this method, right? Always consider that if it was greater than equals to, then you would have considered minus one and one. So then my answer would have been minus 1 to 1. See, from here also 1 was not coming. Okay, that's fine. But I, even though I would not have checked this, right? From here itself, I would have got this answer, right? Minus 1 to 1. Because minus 1 and 1 was not coming in any case. Because here only the equality condition is there, right? Are you getting me? See, if the equation was something like 1 plus x upon 1 minus x greater than equals to 0, right? Okay, that means that condition 0 can be there. So if 0 can be there, then so I can take, right, x equals to minus 1. If I'll put x equals to minus 1 here, the condition will satisfy, right? 0 can come, right? But for this our question, right, x, it can't be 0. So if it can't be 0, I can't take minus 1 also, and 1 to I was not taking, right, because of this condition. Are you able to understand this?
Yes.
You got it, right? Okay. Again here also you can see this is simple, right? X is greater than, x is less than 1, right?
Yes, sir.
Minus infinity to 1.
Yeah. So this is minus infinite to 1. Okay. So I hope the graphing thing that I did, I hope you have already understood, right? So the graphing, I'll just go through it again. So the graphing that I did was, so this was, and then what is happening? Correct. So this was, and this is log of x base a. And this is the condition. This is function y equals to log x base a. A is greater than 1, right? Because whenever you plot, this plot also comes when, so this will be something like 2 to the power x, right? Or 3 to the power x, or 4 to the power x, any value that is greater than 1, or even 1.1 to the power x. Okay, you already know that, right? The exponential function y equals to a to the power x is, if a is greater than 1, then this function goes like this, right? If I'm just saying a to the power x, if a is from 0 to 1, how should I plot this function?
Decreasing.
Sir, that will be reflected along y-axis.
Will it go like this?
Yes, sir.
Correct. So now you would have understood that this, for the till now whatever I was discussing, right? I was discussing for all the logarithm function where the base a was greater than 1, right? Now I'll discuss about the logarithm function where the base is from 0 to 1, because always we bifurcate, right? Whenever you were dealing with the exponential function also, you have studied that the a that was there, right? So whenever you were discussing about the exponential function, you would have bifurcated, right? One where the a was greater than 1, and for one value where the a was from 0 to 1. Okay, it can't take 0, it can't take 1, because okay, because there was some condition, right? So here the first condition, for this condition, so your logarithm function also goes like this, right? Y equals to logarithm of x base a is greater than 1. Now for this condition where the exponential function for which a was between 0 to 1, right? So how should I plot the exponent, the logarithm function? So here you can see that it will go like this, right? because you have to take it the mirror image in y equals to x, right? So this is your function. Now you have to tell me the range and domain for this function, the logarithm function where a is from 0 to 1. What will happen here? What is the domain
Domain
for this function?
0 to infinity, where 0 not included.
0 to infinite. Okay. What about the range?
R.
The range will be R. Okay. So is there any difference in the domain and the range depending upon the base of a logarithm function?
No,
No.
sir.
No, right? For any of the function, so the domain and the range will not change, right? So whenever you have been asked to calculate the domain for any of the logarithm function, right, you just have to check the a should not be equals to the a should not be less than 1. Okay, it should not be sorry less than, it should not be negative. Okay, that is what you have to check, and it should not be equals to 1. Okay, you don't have to worry about whether a is from 0 to 1 or not. So the domain and the range will always be same. So the domain will always be 0 to infinite. You can see that here also the domain is from 0 to infinite, correct? From here to here. And the range, you can see that the range, it can get any value, any unique value, right? And the same is case here also. Either a is from 0 to 1 or a is greater than 1. Okay, both condition are same. Okay, there is something called natural log, and then see, whenever this log, the base a, right, that you're talking about, whenever you consider it as a natural log, so whenever you take it as a epsilon, right, e value, then you call it as a natural log. Okay, and the e value is greater than 1. Okay, that is around 2.71. So whenever the natural log, if they're talking about, you just have to follow all the characteristic of the logarithm function, logarithm of x base a, where a is greater than 1. Okay, because the epsilon is something to the power 2.71 or something. Okay, around greater than 1. Okay, that is what you have to. So whenever the logarithm function natural log has been talked about, you have to use the character of all the logarithm function where the a is greater than 1. Okay, you can plot the function like this. Okay, and then calculate whatever you want to. Okay. And the common, so there is only, but it will be mostly, it will be mentioned in the paper. Okay, they will not be like written as like a natural log or a common log. It will be given something like that. Okay, then whenever the base is 10, right, you call it as a common logarithm. Okay, and whenever the base is e, right, then this is a natural log in the common log. Apart from, you can see that here also the a is greater than 1, here also a is greater than 1. So the properties for all this function will be same as logarithm of x base a, where a is greater than 1. Okay, the same cases, the domain will be same, the range will be same. Okay, you can just okay. Now for all this function also, the small things you can just think of as, if for this type of function, if x will start tending towards 0, the function will start tending toward the value as minus infinite, right? And then x is infinite, the value the logarithm function also will be infinite. Okay, so this is some sort of an increasing function, right? The logarithm. Okay, so first tell me log of x base a, where a is greater than 1, is it an increasing function or a decreasing function? And then you have to tell.
Increasing.
Increasing.
Okay, and what about this? This is an increasing function,
Second decrease.
decreasing function.
Decreasing function.
Okay, that you have seen it also, right? This plot, if you see, as the x value increases, the function of the value also increases, correct? And here you can see that as the x value increases, the function value started declining. Okay, you can see that it keeps on decreasing. So that's why this is a decreasing function and this is an increasing function. Now you can see that at the x here tends towards 0, the function value is infinite, right? And if x tends toward infinite, the function value tends to what? Minus infinite, correct? Here the
Yes, sir.
function value is infinite. So you can see that from infinite to minus infinite, right? So here the function you can see that here it is increasing function. It goes from minus infinite to infinite, right? This goes from where? Infinite to minus infinite, right? So that's why this is a decreasing function, this is an increasing function. Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay. Okay. Now we'll discuss about some of the properties of a logarithm function. Okay. See, there are some proofs also, but I don't think so that those are important for you guys. Okay. So the proof or maybe the laws only. We'll just think about the properties of log function. Okay. I hope, yeah, one more thing. In the inverse function, when you were reading the inverse function, right? You would have came up across any of the inverse function, any function. Let's example a function fx and gx has been given to you, and it has been said that this gx is the inverse of fx. Okay. Now, if I have to write f of gx, what will I get?
Identity X.
Correct. So this for both the cases you'll be getting x, right? That means what? This is nothing but if you have a function f of f inverse, you'll always get it as x, and f inverse of fx, you'll always get it as x. Correct? This though will always satisfy if you have this type of a combination where fx and gx has been given, and gx is the inverse of fx, right? So these two properties will always satisfy, right? Is it clear?
Yes, sir.
Yeah.
Yeah. So that will be satisfied for your logarithm function also. Okay. So let's for example you have been written e to the power x, okay, equals to y. And then you have been given the function, the inverse of that, logarithm of x base a. So if you'll just write it as f of f inverse of fx, or f of f inverse, you should always be getting x, right?
Yes, sir.
Correct. So now, so the if you use this property, right, you will get to know that, see, one thing first, the logarithm of, for example, okay, I'll just first write the this all the properties, and then if you want I can prove it out. But let's first write it out, all the properties that you generally read for the logarithm function. Okay. So the first thing that you read is uh, logarithm of 1 base any value. What will you get here?
Sir, I think 0.
You'll always be getting 0.
Wait.
Okay. Why did you get? Okay, one thing I hope I didn't told you. So if you have been written log of x base a equals to y, okay, how do you represent this? So generally you represent it like a to the power. So this y generally comes as a power of a, right? And then this is equals to x. Correct?
Yes.
And this was the first thing that I should have told you. But yeah. So in if any logarithm function has been given, right, to you, logarithm of x base a equals to y, the simplification for that is like due to this inverse of the exponential function, you will get it something like that, e to the power. So whatever base has been given to you, just you put to the base y, you just put it as exponent of that base, and then equate it to x. Okay, so the logarithm of a number to some base is generally the exponent by which the base must be raised in order to obtain that number. Okay, anything, let's say example e to the power x has been given to n. Okay, and if you have to write it log, so here too you can directly take the log here n, So it will be equals to x, right? And then the base will be. And how did you get? So you can just apply log at the both sides. So log of n base a. And if you will apply here log of a to the power x base a, right? This is nothing but f inverse of fx, correct? And that should be equals to x. So that's how this will be equals to x. Are you getting me? So I told you right now, right? So if you have any function, right, you have a fx equals to a to the power x, and f of inverse you have a log of x base a. Now if you have to write f of f inverse x, so if you'll write a to the power this all value log x base a, what should you get?
X.
X. Okay, so this is the second properties that you are getting. So now from now onwards, what you can just think of as anything a to the power log of x base a, right? You just replace this x with this a. If you'll replace this, what will you get? X to the power log of a base a. So a base a, right? This is equals to 1. Are you getting me or not?
Yes, sir. Not
Okay, so this was the second property. And from where we get it? F of f inverse will always be equals to x. Okay, and the second condition that you can get it as the third property, f inverse. So f inverse is this one. So log of x base a, right? You just write it log in. So f inverse of fx. You just put here what? A to the power x. What should you get here?
X.
X. And how did you get? I told you, right? You can just replace this also. Replace this. Here you have 1, right? So 1 you can just replace with this. So if you'll just replace, you'll be having x log of a. So this is equals to 1. And how? Let's say example you have been written anything x base x, okay, equals to what you will get? 1 you will get.
1. Yes.
Okay. Yeah. But if somebody doesn't know that, I told you how to write any equation, right? From the here. So how will you write? So x to the power what equals to x?
X to
So
the power
1, right?
1. Yes.
Okay. So this is how generally you write, right? Log a base anything x equals to n, right? So you will make it as x to the power n equals to a. Okay, this is very simple. This conversion you should be knowing. If you know this conversion, you can get the value of anything. Okay, so this was the third property. And the fourth property you were already using, right? Log of any number base the same, you will always be getting 1. Is this four properties clear to you guys? Okay, if you want to prove the first one also, right, you can get it, right? A to the power 0 is equals to 1, right? This is correct, right? A is some value that is not 0, that is not 1, right? A to the power any value in a to the power 0, right, you'll always be getting as 1, right? And that is what we have written it here. Is this clear?
yes, sir.
All the properties are clear, right? So
Yes,
this
sir.
two, yeah, and these two properties are important because it will be used everywhere, right? This two properties is very simple, but you just have to remember, okay? What is these two properties? What I have written? Yeah, a to the power log x base a. Okay, this a and x you can represent like replace it like interchange. If you'll interchange, you'll get it as x log a base a, and this is 1. So you have just got x, and that was equals to x. And this property we got it from that inverse ka property. Okay, if inverse of fx or fx of f inverse, you'll always be getting as a identity. Okay, and here also you can just replace a x here, and then you'll just be left with log of a base a. So you'll be getting 1 there, so x will be left. So these are the 3 4 properties, those are important, okay, very important from now on. So this is fifth properties. So the logarithm of log of anything, let's for example this is mn, right, base a. So this multiplication will come out as a addition here. So log of m base a plus log of n base b. Sorry, a is there, right? So a. Similarly, if you have a divide, right, log of m by n base a, so you'll write it as a log of minus log of n base a. Okay, and the seventh property is log of, let's for example, you have a m to the power r a, so you can write it as log of m r times, right, times base. So you can do the summation, you can use this properties, right, and if you use this property, this will be log of m base a plus log of m base a r times, right. So you'll be having r times, you're adding this, so
Thanks,
you'll be having,
Lord.
correct, r times log of m base a. So this property also you can remember. Okay, so this equals to, so this r come out here, right, so r times log of m base a. Is this clear to everyone? Is the,
Yes.
all the properties clear, right?
Yes, sir. Sir, is there any proof of this? This multiplication and division?
Yeah, there are proofs for this. If you want, we can do it, but yeah, that's not important.
Okay, okay, sir.
Yeah. The properties are clear to you guys?
Yes, sir.
Yes, sir.
Okay. Okay, let's try to, okay, so this is, I hope, yeah, the most or less the properties, these are the some of the properties, okay, that you can think of. Mm. See, if you want to have, see, let's, I can just prove it the first one. Those you can just apply it for the second one also. You can just think of as mn, right? Yeah, take, let's for example, anything, okay, x equals to log of m base a, and take y equals to log of n base a, and then if you add it x plus y, what will you get?
Log of m base a plus log of n base a.
Correct. Now put a to the power x plus y, so you'll be having a to the power log of m base a plus log of n base a. Correct, that you can
Yes,
write it
sir.
as a to the power log m base a times a to the power log n base a. Correct.
Yes, sir.
Okay, can you write this as m and
Yes,
this as
sir.
m?
Yes, sir.
Correct, so this is something like a to the power x plus y. And what is this a to the power x plus y? X plus y, x, or maybe apply log, no, log a.
Yes, sir.
Log. Okay, so if you'll apply log here you'll be left with what?
X
X,
plus y.
Plus y.
correct, equals to log m times n. X is what? This, right? And y is this one, right? So you'll be having log of m base a plus log of n base a equals to log of a mn. Correct? Is this clear?
Yes, sir. It is clear.
Yeah. Okay, so yeah, that's not important, but yeah, it's fine. Let's move to, let's try to solve some problems. Okay, yeah. Do not get confused with this log of m plus n base a is equals to what? This is not equals to log of m plus log of n base a. Okay, sir. Okay, this is not equals to log of m base a minus log of n base a. Okay, I hope this should be there in your mind. Is the properties clear to you guys?
Yes, sir.
Okay. Let's solve some problem using this all these properties itself. Okay. So if I have to solve this type of a problem where twice of log x 0.5 equals to log of 0. Sorry. Okay. What will be the value of x?
2.
X will be 2. Correct. That you can see it, right? You can just put the value here 2, right? X square 0.5 0.5, right? So x can be 2. Hmm. Okay. So somebody doesn't are solving with this approach. Okay. What can be the other approach to solve this? So-
We will take 4 as a 2 square. Then
Okay. Yeah, that also can be correct. So generally, x square equals to 4. So x equals to plus minus 2. Why can't I take minus 2?
Because this is not in the domain, it is
Correct.
restricted.
Right. X should be greater than 0 also, right? The domain is x greater than 0. So that's why x can't be minus 2. Okay.
sir, question number 3 from activity question
Okay.
1.
Okay. I'll go through it. So what is the question? AQ? Which one?
Question, third question, sir.
3.1.
1.
So 6.1, right? Question number 3. Okay. I'll take that. So this is clear, right? Now solve this log of x plus 1 base 8 plus log of x minus 1 base 8 equals to 1. Till the time I'll just write the question. Okay.
So change of base rule here we will take.
Sir, x can be plus minus
Log
3
x plus 1 to the base e divided by log 8 to the base e plus log x plus a minus 1 to the base e divided by log 8 to the base e equals to 1. In this way, can we solve it?
Yeah. What did you say? Can you come again?
So can we solve it by change in base rule
But
property?
okay, base rule you can use it, but base rule that the change in base rule I have not taught, right? Like I have not. Okay, that is simple, but I'll, yeah, without using that, can you solve it?
Sir, this question, right?
Yeah, yeah,
Using log addition also.
Sir, I'm getting x as plus minus 3, but minus 3 we cannot take. So x
yeah.
should be 3.
I am also sir getting plus minus.
Oh, yeah, correct. So this is like
Yeah.
log of x base 8 plus log of y base 8, right? So this can be written as log of 8
X
x,
into y base 8.
correct? So
Yes.
n equals to 1. So that is basically what? X times y is equals to 8, right?
Yes, sir.
So if I'll write x is what? X plus 1 times x of minus 1 equals to 8, right? So then
X
you
square
can
minus 1
Square
equals
minus 1.
square minus 1 equals to 8. So x square
3.
equals to
Square is 9.
x
3
equals to plus minus 3. So minus 3 can't be
minus
the
is
answer.
not a, so 3.
Hmm.
So we can
Okay.
do by taking 8 base x plus 1 and x plus x minus 1, and then log 8 uh, bracket x to the power 2 minus 1 equal to 1.
Yeah, that also you can do. Okay. So we have to discuss about the change of base rule also, right? That is not that is also same.
The change of base rule.
Okay, AQ, which one, which question you were asking about?
Sir, question number 3, 6.1.
Let me write. So the question here is fx equals to, what is that? Log of x base 10 whole square minus 8 of log of x base 10 plus 15. This is the question, right? You have to calculate the domain.
Yes, sir.
Take this as capital X. So log of capital X square minus 8x plus 15. This should be greater than 0, correct? So x square minus 8x plus 15 greater than 0. Now solve this equation. What are the value that you are getting? X minus 5, x minus 3, correct? Greater than 0. This is 3, this is 5. What are the values that you are getting? If you'll just put any value less than 3, is this satisfied? This will get satisfied, right? So this will get satisfied. So minus infinite to 3, 5 to infinite, correct? So this is x. This we are talking about x. Who asked the question? Are you able to understand this?
Sir, can you scroll up?
Sir, can I see the full
Yeah.
answers?
Sir, what is the base here in the outer log?
Outer log, if it is not given, take it 10. Like,
Okay.
yeah, 10 is given. So see, whenever you have been written log, right, and then base is not written, take it 10. And if it is ln, then you take it as base as the exponential base.
Okay, sir.
So have you understood this? X will be what? X will be something. Oh, sorry. In the end, what you are getting? X should be less than 3 or x should be greater than 5. What is x here? X, what I have considered? Log of
X base 10.
10. Correct. If this is less than 3, what should be the value of x? X less than 10 to the power 3. And if log of x base 10 greater than 5, what should I get here? X greater than 10 to the
10
power
to
X
the
5.
is
power
greater
5.
than 10.
So the answer should be minus infinite till 10 to the power q union
10 to the
x
power 5
till
to
infinite.
infinity.
5 to
Yes, sir.
Is there any other any options or something like that? That will be the answer. Okay.
Sir, that is why we are using log, right? Like here, this is a very good, like very big number, 10 to the power 5, and we
Mm-hmm.
have reduced that.
Correct. Yeah. So
Okay.
yeah. Have you understood? So what I did is you can just take this because it was very, so you can just calculate it something like taking log of x base 10 minus 8 of log of x base 10 plus 15 greater than 0, because this should be greater than 0, correct? Because to get the correct domain, right, this should
Yes.
be greater than 0, right? So what I did, this you can consider it as x as of now to simplify the calculation. This should be greater than 0. From there you can get the value of the condition on x. But what is x exactly? The x is log of x base 10. So then from here you can get the condition of the small x. Okay, the small x is the one that has been asked in the problem. Okay.
Okay, sir.
Yeah.
So here it is minus infinity to 10 cube, right?
So here it will be 0, sorry, because it will be
And
0, right?
okay.
Because it can't take anything less than, yeah, because here also this x also should be greater than 0, right? Because
Yes, sir.
log of x 10 base. So for this also the domain x should be greater than 0, right? X can't take anything less than 0. Okay, so the answer, the correct answer should be this one. Is this clear to everyone?
Yes, sir. Thank you, sir.
Thanks. Okay, let's try to solve this. Yeah, one more thing. So if you have something like log of x6, so this you can write it as log of x. You can change the base basically. You can write the same base here, and then x of this a times b. So what you are doing is nothing, right? You're just whatever the in the exponent term, the number that has been given, right, for which you have to calculate the logarithm. You can directly write it as here, and then the base you can just write it as here. So what I'm doing is, let's say example log of x a base b, right? So what you can do is log of a, okay, because a was here, so you have just written the numerator, write the any base, okay? So you can just write base here is anything, and then log of whatever base was there, right? So here you can write it as b, and then here also the base you can write it anything, but the both in the numerator and the denominator, right, the base should be same. Okay, so this you can do.
So if A is greater than 1, we can take B as less than 1 and greater than 0, right?
But what?
If A is greater than 1, let's say, then
Mm-hmm.
we can take B as less than 1, right? I mean greater than 0 and less than 1.
No, so are you talking here? One
Sir,
second.
in this base change only.
Here, huh?
Sir, just the upper one.
Okay,
Uh,
the upper one.
just scroll up, sir.
Okay.
So here.
Hmm.
If A is greater than 0 in the left side, sorry, A
A
is
is
greater
all.
than 1,
A is yeah, A is greater than 1.
then we can take B as less than 1, right?
You can take anything, any b you can take. There is
Okay,
no
okay.
restriction on b. Yeah, but b should be same. Okay, numerator and denominator. Okay.
Okay, sir.
Yeah. Okay. Let's solve this. If you have a question, something like e to the power minus x square is equals to 2 to the power x ka whole square upon e to the power cube. Calculate for x. See this week, the whole all the properties only you have to use it. Okay. I hope all the properties we have discussed. Okay. So only property you have to use it and then solve the questions. Okay. Nothing difficult in this week. Okay. Right hand side, what can I write?
Log, we will take log both
Both
sides.
side you can take
Okay, logarithm we can take it, but first I want to e to the power x ka whole square. What should I write here? E to the power x square
2x.
or e to
You
the
can
power
take
2x? What
e
should
to
I
the
write?
power 2x, it should be.
Okay. E to the power 2x, right? Do not get confused with this. You can't write this. This is not equal. So here you are writing e to the power minus x square equals to e to the power 2x minus 3. Correct? And then you can take log. Take base e itself. Okay. So that will be easier. Take ln. Here also take ln here. Then what will happen here?
Minus x square
Minus
equal
x.
So x
to,
square will
Yeah,
minus
minus
3.
x square is equals to 2x minus 3. Correct? If I'll solve it, x square plus 2x minus 3 equals to 0. Correct?
Yes, sir.
Yeah. What should I get? X plus 3, x minus 1. X equals to minus 3, 1. Which one I should be taking?
1.
Why 1? Why
One.
can't I take minus 3?
Because for the log is
From
ought to
0
be
to
positive.
infinity.
No, no, but we were solving this question, right?
Yes,
Just
sir.
put x equals to minus 3, whether it is satisfied or not. See, here this function, so we just took the help of logarithm, right? From the initial, the question was not in log, right? Just we took the help of log. If
Okay,
it
sir.
was something like
Both can
log of
be.
something, right? So is minus 3 can be the solution? Just put the minus 3 and then check it. Is this not satisfied? See, for this question, x can be anything, no? This equation, x can be anything, right?
Yes, sir.
Right, so we can't exclude x equals to minus 3. X equals to minus 3, we would have excluded if we would have checked. So whenever you're solving, check it whether you can put it in the solve. Like if it was something like log of x, right? Then you can't take minus 3, because at minus 3 the function is not defined at all. Okay, for logarithm function, x can't be in the domain. Okay, see this x can't be negative. Okay, the negative value can't be in the domain of logarithm function, but it can be there for exponential function, right?
Yes, sir.
Is this clear to everyone?
Yes, sir. It is clear.
Yes.
Okay.
Yeah.
So this type of problem you get it in exam also. Solve for x. Or you just tell me the number of values of x. Number of values for x, for values of x for which the function satisfies. Okay, and then tell me the values of x also and the number of also. So you can be asked in the exam the number of values of x for which the function will be like you can get the solution or the exact solution what you got it.
9x minus 2 into 3. I think you have left minus there.
Oh, sorry. 9. Is it fine now? Yeah.
One value of x is 2. One of value is x 2.
One of the value is x equals to 2.
Yeah.
Whatever the other?
3 minus 3 is coming, I believe.
My other is 1.
This one. One is 2.
No, 1 will not satisfy. I can't see 1 satisfying here. If I'll put x equals to 1, 9.
X is 2 is satisfied.
Yes.
9, that will not satisfy, right? 9 into 2 is 18. Oh, is satisfied, huh? If I put x equals to 1, that is not satisfied, right?
And x equal to 2. That is it. There are two answers. The one is minus.
How many of you got? How many of you have got the answer? Okay, let's solve it out. So how did you solve? You can just consider the what? T
I
equals to
consider 3x equal to a or
3x as t.
t.
Yeah,
3x
3x we
as
can
t.
consider.
We can
And the
okay,
value of
consider.
a
Then we are
is
getting a
minus
quadratic.
3 and 9.
right. So then you'll be getting t square minus 60
60
minus
minus 27.
equals to 0. Right? This equation everybody is getting, right?
Yes.
And then if you are getting this, then it becomes simple, right? T, what is this? Minus
Minus
9.
3 and 9.
T plus 3. 27, right, equals to 0. So then to the power x equals to 9, to the power x equals
Yes.
to minus 3. This is not possible. Why this is not possible? Because exponential function you have read, right? X for this function, what is the range? 0 to infinite.
0
Right?
to infinity.
Minus 3 you can't get it, right? So for this you can't get any value of x, right? Here you can get it, x equals to 2.
This two.
So the number of values of x is 1. What is the solution? Is 3. Sorry, what was the solution? 2. Sorry.
2, 2, 2.
And
I hope this is also clear, right? Okay, if you have something like 5 to the power x minus 2 to the power 3x plus 2. Solve for x. Okay, what about if we have a function fx equals to logarithm of a, what is the domain for this function? A is like greater than 1. Solve this too.
Can we take ln function in the first question?
Anything you can take. I guess for this question you'll be getting some very like The answer will not be anything integer or something. It will be very clumsy, like not good. So at least the method you know, right? So how can
We
you
can
take?
we can take log both sides, right?
Okay, if you'll take log both sides, x minus 2
Log
log of
5,
5 equals
3,
to 3x plus 2
log of 3.
log of 3. You are taking base anything, you can take it.
Yeah.
Okay, that's not a problem, right? So now
Answer
you have to calculate x, right? You can just put x one side,
So
right?
is the answer is minus 3.21?
Might be possible. Might be. So if I'll just take x here, so we'll be left with log of 5, and from here we'll be left with what? 3. Sorry, not plus. This is minus, right? Minus of 3 times log of 3 equals to 2 times log of 3 plus 2 times log of 5. So x equals to, this would be something like, what will you get? You can just put it here also. So this will go, this will go. So we'll be left with
log 9, log 25.
log 9 and log 25, right? So log 9 times 25, correct?
Yeah.
And here what will get? Divide by log of 5 upon 27. This would be the answer, right? Is it correct?
Yes, sir.
Okay. Yeah, this is not an teaser you'll be getting. There's some clumsy answer you are
Yes,
getting.
sir.
What about this question?
Sir,
Everybody
here,
solved the first one. There is nothing. The only all the calculation only. Yeah. There's no even properties. Once only you just have to use the properties here. That's it. Yeah. What will be the domain for this question?
sir, domain is real line except -1.
Correct. Anybody has any confusion in this? R minus minus one. Okay. Any confusion in this? Calculating the domain for this function. So you can see that this function mod of x plus 1 greater than 0, right?
Greater than equal to 0.
No, this is not for the domain, right? Greater than 0, right?
Yes, sir.
So this will always be positive. Okay, only it can go to 0 and at when x equals to minus 1. So that's why we are just removing x equals to minus 1. Is this clear to everyone?
Yes, sir.
Okay, let's solve the last question. So see, this week was very simple. So I'll just, if you have any doubt, you can just ask. But otherwise, I hope everything was covered. So log of x plus 1 base 2 minus log of x minus 3 base 4 equals to 2. Solve for x.
In previous question, sir, it maybe it is 2 log 15, sir,
Where?
divided by log of 5/27.
Oh, yeah, here. It,
Yes, sir.
no, sorry. Not here, right? Not here. Where?
No, so 9 into, you have written 9 into 25, sir. There must be.
This 2 I got, right? 2 went here. 2 went here.
First, I have taken, sir, like log in both sides, and then I have put it powers also.
Is I feel it's correct only, right? Where? Okay. So this is x. This came here, x. This 3 came here. This 2 times log 5 went here. 2 times log 3 went here. So this 2 I just removed and wrote it here. This 2 I just removed, wrote it here. So now I have log of 9 plus log of 25. So that I can write it as log of 9 into 25, correct? What is the mistake here? Is there any mistake here? I can't see anything. Are you able to hear me?
Yes, sir.
Is there any mistake that I did, like any calculation mistake or something?
The calculation mistake is yes, sir. Mm,
No mistake, right?
yes, sir.
Hmm. Oh, yeah. Solve this one. Yeah, this would be the last question for today's session. If you have doubt, I can take the doubts. But yeah, from my side, this will be the last session. The question. Yeah, one more thing I have to discuss. Yeah, the logarithm inequality, right? That I have not discussed. Okay. Okay, solve this and then after we'll discuss that.
Value can be fraction, rational number.
We'll get some integer value, I guess.
Sir, is it 7, sir?
Yeah, 7 is correct. Okay, so how did you solve? So you can just write it as log of x plus 1 base 2 minus log of,
Sir, I have taken base 4 is equal to 2 to the power 2, sir.
okay, x minus 3. So this 2 you can write it here 1 upon 2, correct? Yeah, this
Correct.
properties I hope you might be knowing.
Yes, sir.
So log of anything, let's for example a square, right? X, you can write it as 1 by 2 log of x base a. Okay, these all properties will all are derivation from the property that we have discussed, 5 6 properties. Okay, or log of a x square, you can write it as 2 to the times log of x base a.
Sir, can you derive this property, this first one, 1 by 2?
Can we solve it by using ln? If you can.
Yeah, ln also you can use it.
So I've used ln x plus 1 divided by ln 2 minus ln x minus 3 divided by ln 4. So I have solved that equation.
Okay, that with that also it can be solved. I'll solve that. But first somebody's asked this, right? Just think of as the proof. Okay, let's say example. You're just taking log of x 8 square equals to some y. Okay, right? So that means what? A square times y equals to x. Correct? Or you are taking this value half log of x base a equals to y. Both are coming out to be same, right? So how will you write this?
Okay.
You can just write it as log of x a equals to 2y, right? So 8 to the power 2y equals to x. So here also you are getting the same thing, right? 8 to the power 2y equals to x.
Okay,
Are you
sir.
getting? You got it, right?
Yes, sir.
Okay. So this
If
property
you
is
can
keep in
show it
mind.
through ln method.
This one, huh?
Uh, yeah, the equal to 2 1 equation. Log 2 base 2 x plus 1 minus log base 4 x minus 3, that one.
Okay, okay. Keeping some values, huh? That also you can do. Huh? Yeah, I hope this is done right. Let's solve this problem, right? Are you talking about this question, right? So if you
Yes.
just solve it, what are you getting? What will you get? Okay. So now you have base, both base are same, right? So if both base are same, then you can write it as, how can you write it? So this is log of x plus 1 base 2
2 log,
minus
we can take multiply by 2, sir.
log of, multiply also you can do,
Sir,
or you
sir, we
can,
can keep
To get
that.
rid of, sir, that numerator, denominator 2, sir. To get rid of 2.
that also you can do,
We
or
can
you can
write
do
that
this also,
as
right?
to the power half. Yes.
Yeah, this also you can do, right? This half I already told you, right? Uh, Log of a base x to the power n. This n you can write it here directly, right? Or whatever has been written here, you can write it here. So here what is written? Half log of whatever it is x base a, right? This half can go here directly. Okay, so that is what we have done. Half can go directly here. With practice it will come. Okay, there are some time properties. You keep on practicing, you will get to know. Now what is left? Log of base 2, right? And then x plus 1 x minus 3 root equals to 2. So if you equate it, what will you get? 2 square equals to x plus 1 x minus 3, right?
Yes, sir.
Yeah.
Yes,
So
sir.
now, yeah, and then, okay, sorry. If you'll solve this, you'll get it right. X plus 1 equals to 4 times mod of, not mod,
Minus
square.
16,
You can do the
bracket x
square.
minus 1. Yes, sir.
16. So this will be 16 times x minus 3 equals to
Yes,
x
x
plus
plus
1
1.
power square.
So
And I
that
guess
will
x,
x
yeah,
square plus 2x plus 1 equal to 16x minus 48.
yeah, x square plus 2x plus 1 equals to 16x.
60x minus 48.
Correct. So x square minus
So
14x minus
plus
49.
49. Plus 49,
Oh,
sir.
sorry, plus 49.
Minus
And this
4.
is
Minus
minus.
14x, yeah.
Yeah, so x, yeah, this becomes x minus 7 power square.
7
So
is equal. X equal
this
to 7.
is correct. Yeah. Anybody has any issue in this? It
No,
went a
sir.
bit fast, but yeah, these are all just properties. So there's nothing
Understood.
new. You understood, right? So there's nothing difficult in the whole logarithm. Okay, it's just that the proper how nicely you can use the properties. Okay, so all these 5 6 properties, and these are properties that you will be using again and again. Okay, log x base n to the x log x to the power n base a. Okay, these all things you will be using again and again. So these all things you should remember or not remember, but yeah, you will get to know. Okay, this a you can directly replace it here. A to the power something also, this thing you can keep on replacing. Okay, so this properties you'll use it again and again. Very important property. Okay, this change base and all those things you'll not be using much, but these all properties you'll be using again and again. Okay, one thing I just left that I'll discuss. Okay, that will be the final thing for the logarithm. Okay, logarithm inequality. I was discussing something right in the starting. Logarithm inequality. Hmm. So what I was discussing was, you already know that, right? If let's for example log of, I was discussing if a function x greater than y, right? So log x is greater than log y, but there is a condition on the base, okay, that you have to take care of. So we already know that logarithm of logarithm of log of x base a is an increasing function if a is greater than 1, right? And if log of x base a is a decreasing function if a is from 0 to 1, right? So now x is greater than y, and if I am applying log x is greater than log y, that means a must be greater than 1, right? So if this is a increasing function, right? If x is greater than y, for x, any x greater than y, right? If I'm just saying log x is greater than log y, that means a must be greater than 1, right? If a was less than 1, then the inequality would have changed, right? So I'll just write it out. So these all things you can just remember. So x base a is greater than log y base a. So this implies one thing, y will be greater than x on for what condition? If a is greater than 1, okay, and if x is greater than y if a is from 0 to 1. Is this clear to you guys? This property, this linear logarithm inequality, is this clear or not?
Yes, sir, it is clear.
This is clear, right?
If you can reiterate.
Okay, what I'm saying is, an inequality has been given to you. Log of x base a is greater than, sorry, less than log of y base a. If I have to imply something, right, what can I imply on the relation of x and y? So this depends on the base a. If I have to write same inequality, y greater than x, this can happen only when a is greater than 1. Because why? Because see, if a is greater than 1, then this function, log of that function will behave it as an increasing function, right? And if log of x is less than log of y, then for sure x will be less than y, right? Because we are dealing with something increasing function, right? This is an increasing function, right? It is an increasing function, right? So at this point, let's for example this is x1, this is x2. At this point the function was y, the value was y, and this is x. So if I'll take log of y also, then log of y will always be greater than log of x, correct? This is what, this is log of y, and this is log of x, correct? You can see that x less than y, right? That means log of x is also less than log of y. And why did it happen? Because a was greater than 1, that means it's an increasing function. Is it clear? And
Yes.
if I have to say x is greater than y for this inequality itself, that will happen when a is from 0 to 1, and that you can see it from the plot itself. How does the plot go if a is less than 1?
Sir, a decreasing function that will be.
From second quadrant to it goes to.
It goes
Sir,
like,
as x tends to 0, that will,
okay,
yes.
okay, now you can see that,
Yes.
yeah. So you can see that this is x, and let's for example this is y. Okay, so you can see that, right? This x is lesser negative, right? So this is greater, right, than as compared to y. So that's why the inequality changes because this is a decreasing function. Are you able to understand or not now? So this
Yes, sir.
log of x, okay, and this is log of y. If log of x is greater than log of y, not log of x, so sorry.
Log of y would be greater, no? Y is.
No, here it will be not
Acha, acha,
applicable
acha,
because
more
this is,
negative. More negative.
yeah,
Yes,
yeah.
yes.
So you can just
Negative.
think of as here.
Yes,
You
yes.
can
Got it. So yeah, yeah. Sorry, sorry.
just think of as here because this is x and this is y, because this was negative, so maybe you'll get confused, or maybe it's not defined also, okay? So what I'm trying to say is this is x, right, and this is y. So this is x, this is log of x, and this is log of y. Here it was said log of y is greater. Okay, so here you can just think of as, okay, maybe
Yes,
it's
decreasing
little.
function.
Yeah, this
Yes,
is a decreasing function, so that's why
strictly
the
decreasing.
inequality.
Hmm.
Yeah. I hope this is clear to you guys or not. How does the inequality occurs? Okay, is this
Yes,
okay?
sir, it is clear.
Clear, right? So let's the second case. It has been given if a is greater than 1. Okay, then what will happen? Then log of x base a less than p. What will that imply?
Sir, meaning what is the question here? I mean,
So what will the condition of x? How can you write x?
okay.
X will be, this is simple, right? From 0 to a to the power p. Correct? Here it is simple because a
Yes,
was
yes.
greater than. So this is a normal condition that you every time write. Now the third condition is if is a is 0 to 1, then if it has been given log of x base a less than p, then what should I write for x?
X should be greater than a to the power p.
Correct. Okay. Yeah. I hope this is clear to you guys. And if it was given as log of x base a greater than p, then you will write it as x greater than a to the power p. And here it was log of x base a greater than p, then you will write it as x is from 0 to a to the power p. Okay, so inequality changes if the value of a is from 0 to 1. Okay, so normally we every time we write it this, right? But you have to think like that should be there in your mind that you're just dealing with where a is greater than 1. Okay, am I clear to everyone? Are you
Yes,
able to understand, right?
yes, sir.
Okay, so that was it from my side for the um, logarithm function. If you have any doubt, you just let me know.
Sir, I just have a doubt in activity question of week 5,
Okay,
exponential function.
so that has not been discussed. So we have some sessions, right? 2, 3 sessions where we just discuss activity questions.
Okay, okay, sir.
So that can be discussed there. But yeah, even though if you have checked with there, then I can discuss. Yeah. Yeah. Anybody has anything? Okay, first we'll go through whatever we have discussed, right? We have discussed very less thing today. There was nothing much to be discussed in this week itself. So if you'll just see, like, and from every week you'll be getting the similar like 25% of the weightage. So there you just have 5, 6, what do you call, like properties of the logarithm. With the help of that properties, I hope you'll be able to solve each and every questions. Okay. So any doubt that you have faced it today?
No, no doubt as of now.
Okay. So yeah. So week 5, right? Which question you were talking about?
Sir, week 5 activity as like 7, I mean the 7th activity question, last one.
Okay, what is this about?
Sir, 5.7 last question.
Yeah, I'm just opening the portal. Okay, so it has been given, the function fx has been given to you. Fx no
Sir,
x.
I just
Hmm,
have doubt in this fourth option, how it is correct. I mean, how to solve this? What should be the approach?
Okay, so this though you can just solve it from, but just from the option only you have to solve it. It's like a hit and trial only. You can't get it this. So you just have to put in fx. You have to put hx, right? And then
Can
same
Okay,
you
that for
paste the
x. Yeah,
question?
like
Can
we
you
have to
paste the
prove
question
this,
here?
right?
yeah. So f of hx you put, okay, and then h of fx you put, and then check what are the condition for x where you are getting that. So you have to check for h of fx should be greater than f of hx, right? This is what you have to
Yes,
solve,
sir.
right?
Yes,
Yeah,
sir.
so this function you have to solve and check for which of the value of x you are getting that. And if you are getting from 0 to infinite, then it's a correct option. You're not getting a.
Uh, no, sir. I mean, I didn't know the approach to solve this. Like, if we want to disprove something, we can have some counter example. We can like put that example. If that is not obeying, then we can say that it is incorrect. But
Mm.
here we have to say that it is correct for all the x belongs to 0 to infinity. So, what is the
Then,
mathematical approach
okay,
to
then you'll
solve
have to
that?
solve that equation.
Okay,
Some
okay.
extreme
So,
condition, yeah.
I
Some
see.
extreme. See, if you have to just solve it from the option, some extreme condition you can check it. See, this option is from 0 to infinite, right? Just check for
Okay, okay.
0. If it is satisfying for 0, you can take 0 if it is satisfying and take any random value, 5, 10, anything. If it is satisfying both, there is a 99% chance that it will satisfy.
Oh,
Okay.
okay,
Yeah.
okay.
You just have to
Otherwise,
check
we
for the
can.
extreme cases. Yeah.
Okay, sir.
You
Otherwise,
got
in
this.
we can put the equation on both side and we can solve that inequality, right? And if
Ah,
we
that
are able to get that x belongs from 0 to infinity, then we can say that it is correct, right?
correct. Yeah. So that will
Okay.
take a lot of time, but yeah, if you have to just give, because there are a lot of options, right? 7, 8 options has been given. Then
Mm-hmm.
without solving, like you can't solve it like in the exam also. It's just that hit and trial you have to do. Okay. For each option,
Oh,
you'll have to check. Maybe for 3, 4 options, they have given already the value. 0 at 0, you have to check it. So those things you'll have to put it and then get. Okay. For
okay,
some
okay, okay,
values, it has been given. So you just check the extreme condition. Okay. And then you'll get it.
okay, sir. Okay, sir.
Yeah.
Okay, sir. Thank you.
Thanks. Huh? Anyone else has anything? How was the exam? How did it went?
It went well, actually. Not well, yeah, but I would say well. But there was
I don't know.
some.
When I was just going through the result, okay, the marks it and all, I was surprised that see, most of the question I've already in the session that I took 1 day or 2 day before the exam.
Yes,
Half of
yes.
the
Yes,
question
sir.
I've already discussed, right? And then also, and people were doing the same mistake. I was surprised to see the result.
I would like to highlight you here. Like, I have marked one question I quite remember very clearly. Like, it was minus 13. To ideally, I should be taking 13, but my bad, I took as minus 13. That I got it wrong. But two
Which question?
other.
SSQ?
Yeah, no, no, I
Sorry,
remember.
SSC, like some of the
Quadratic, yeah, minimum. You take the minimum of it.
okay.
That
Hmm.
one. So
Okay.
instead of 13, I took the exact answer minus 13. So that's my bad. That's on me. But race two, transitive, question number 4 and 6. I marked it correctly, but I didn't got the right answer. But I didn't got was not awarded the marks there.
No,
But
have you checked the answer transcript that you have got it?
I check the transcript, but the transcript, whatever answer it has recorded, that is not the answer that was marked by me. That is the issue what trying to highlight in many sessions. And
Okay.
one of the girl,
Okay.
she has
Is it
also
like,
facing
is it
same issue.
just for the maths or it happened
No,
for the other
English
course?
also. English also.
Okay, can you
I've
just,
taken only two subjects, English and maths.
okay, I'm just writing my mail ID in the chat box. You can just convey this, like I'll just forward it to me. I will just check with the team because maybe I'm just writing mail ID. Okay.
Okay.
Sir, what is the highest score?
Highest score, somebody got full also.
Yeah, 100.
Okay.
I think 100 was not hard.
See, I reduced the number of questions also. Okay, earlier it was 14, 15. I reduced it to
Mhm.
12 questions. Okay, so that will be easier.
Will the
Then also,
quiz 2 be harder than this?
it will
Tougher?
not. No, no, it will not be tougher. No. So the quiz two also paper, I have, like it's a very simple paper. Okay. But this was also very simple, right? And only what I saw, 40% of the student passed it. Okay, leave about getting highest and getting good score. 40% of the
Passed it
students
as in like just
got
passed
40
or
marks, just pass 40 marks. So that
oh,
is, yeah. So that was bad, right? So that then I got like, okay, the paper was very simple, and then so okay.
What is the
And this
why
time, sir,
am
you have removed also the graded assignment points, sir, also.
What?
So this time you have removed the 10 marks of graded assignment.
The graded assignment similar questions was there, right? I guess from week 3 it was there.
No, I'm saying that overall score, sir.
Yeah, overall score we have removed because we wanted to give the similar question in the graded from the graded assignment to the exam. So again, I'm telling you. So in the quiz 2 also. So leave apart similar in the quiz 2, right? You will be getting exact same question. Okay, I will not even change the number. Okay, exact question from
Yes.
week 5 to week 8. Okay, there will be some 10 marks of questions. Okay, 10 marks means 10 marks out of 100. So that means 5
from the
marks out of
graded?
15. Yeah, from the graded.
Sir, in all three exam, quiz 1, quiz 2, and term, 10% weightage will be there, right? From graded.
Yeah.
Then it is like somewhat like similar to the previous grading pattern.
Yeah, that is what I'm saying. Grading
Just
earlier, the
because people used to use ChatGPT and
Yes, yes.
copy and do things like
Previously,
that.
people can
To
copy.
avoid those all those nuisance, these steps has been taken.
yeah, correct.
What will be the syllabus of quiz 2? It is from 1 to 8 or 5 to 8?
No, week quiz 2, right? So this is
Yeah.
week 5 to 8 one. There
Also,
won't be anything.
I today I came across a quiz for the mock quiz of 1 to 4. Was that graded? Like, did
Mm,
that hold any weightage
No,
marks?
that doesn't hold any weightage, but
Sir, for
keep
bonus,
solving. Yeah, so for
Okay.
bonus you have to, but yeah, solve like whenever we are giving right mock, you have to solve. Just not for the like it will be considered for the bonus. You'll be getting some 2 extra marks or 3 extra marks if you are submitting. Okay, and
Oh,
yeah, so it's like your marks will be evaluated out of 103 or 104. Okay, like depending
okay.
upon what you have if you are submitting bonus or not.
No, it skipped my like
But
I
okay, you can
skipped
submit the remaining
submitting that
two, and then if you are just submitting the remaining two, also that is you'll be getting full marks. Okay, so 2 out of
because
three.
in English now the mock was like just for practice.
Okay, I can
So
Sir,
no, no.
even I didn't submit the mock test, sir. The
Okay,
first
that
one.
is fine. The remaining two you can submit. Okay, I'll. That's why I released it 1 week before itself, and I hope in the session also it has been said right
no,
to
for
attempt the
actually
mod.
for few people who are working, two subjects also becomes so much overwhelming with the lectures, back-to-back
Yeah,
assignments, and things like that. So it becomes very tough to manage.
yeah,
So
I can
something or the
understand.
other passes to the through the crack. So
Okay.
it's very hard
Okay,
to
so now,
manage.
yeah, now itself I'm saying mock again. It will be released as a. You just submit it. Okay, solve. Sit for an hour and solve it. That is generally for the just so that students would attempt those. This mock and
Okay.
all. Yeah, so you'll be getting some 2, 3 or bonus marks for that.
Okay.
can you
Please have a
extend
look
the
now. I will
deadline?
share you the questions, all the issue. Please
Uh-huh.
have a look on that.
Okay. Yeah, on the mail ID, just explain the matter
Yeah.
that you have faced it.
The issue was in English pair also
Okay.
because, but I am sure
Yeah,
it will
but
be
yeah,
rectified now.
from next time, whenever you are some, so after every question, you just save it, okay? Because whenever
I saved it. Like, for example, if I'm telling
I
one
got it,
question were there,
hmm
yeah, I saved it properly. I saved it. I again revisited it and then submitted.
and after saving also after every 25 minutes, you save it like the whole paper, okay?
Was
Uh,
the thing the system is so redundant and so the
okay,
exam center, every
yeah, so
SBI, every bank, every LIC, every PSU examination are taking at that place, and they are not at all upgrading their hardwares and all. So
okay.
that might be an issue.
Yeah, but whenever there are some issues that happened, okay, we try to convey that, convey to the center, okay, if something like till now we have not got any any of the bad feedback from the, so whenever we
No, no,
used to
this
get,
is
yeah.
also the first incident. Last year I took the exam, but I couldn't continue after quiz 2. After quiz 1, I would say.
Okay, okay,
So I took the exam. Yeah, I got a flying marks in the English,
okay.
but this time also it was okay, but I didn't know how the things went bad,
Oh, okay.
the grading and all.
Okay, we'll try to check like for whichever center, or mention about the center also, so that from our backend we'll check whether any problem happened or not. Okay. So we
Okay,
generally get all the data related to every centers. Okay. So we'll try to check the timing and all from there. If we'll are able to get something, we'll get back to you.
okay, okay.
Okay.
And what is the extra time given for?
What?
There was an extra time of 40 minutes that was specified there. What is that for?
40 minutes for what?
I mean, they the thing in exam on the time next to the time they say
Mm.
40 minutes extra was there. It was showing 40 minutes, including extra time 40 minutes.
I'm not aware of that, but yeah, if you have some three paper, you'll be getting 3 hours of time. Whatever I know, for four paper, you'll get 4 hour of time. There is no extra time as such.
Yeah, I was also wondering what is that, because even though I submitted by this thing 3:30, because I had only one paper this time, so
Mm-hmm.
I submitted. What I see is that it was showing something extra time of 40 minutes or something. I don't know what was it.
Okay. I'm not aware of that, about the extra timing.
Okay, then fine, thank you.
Okay, so we'll meet in the next session. I will have a next session on Tuesday. So we'll try to wrap it up. So we'll solve some problems. Okay, if you have some doubts also, you can come up with the doubts the day after tomorrow. Okay. Yeah, and whoever faced the issue, you can just mail me out. I'll try to check whether what happened to that center.
Okay, sir.
Okay.
Sir, in the last term, I attempted the qualifier, and in that term, actually, I had in qualifier actually four subjects will be there. So in my center, no one was there towards the end of the exam. So
Panic.
the yes, sir. So literally no one was there. So those exam staffs, those invigilators were forced me to like complete the exam and like
Yes,
finish.
yes. This also happened
I
to me.
yes,
Yes,
sir.
yes.
And
No,
I
those
like
things you can
made
write it, right? If they are doing those things, then you can write it to write us the mail. Okay, we'll try to check with is that happened or not. Okay, that's like 4 hours it have been given. Okay, nobody can force you
No,
to submit it
actually, the
before end.
issue is
so they forced
different
me
people
first, and
come
then
to attend
they
the
like
exam. Like
then
some
they
have
gossiping
NPTEL
around me.
one paper, some have two papers, some have four papers. So the invigilator or the people who are in the center, they are also not aware what is the exam period or the length of the
No, but in
examination.
the hall ticket of yours, it will be written, right? How many papers you have, right?
Yes, sir.
Yeah,
So
yeah, but
they were aware about this fact, but like
Because they have to go it like maybe they
yes,
are
sir,
forcing.
exactly.
But yeah, you
people
can say that.
generalize.
Uh-huh.
As 10 of people have left, why only he is sitting or why she
Correct,
is
correct.
sitting.
Yeah, but somehow you have to fight for like you say, like okay, that you can convey this to the
Sir,
invigilator, and
even I
there are.
faced them. Like I said, I have time. Like I
So
have
what
time
happens
in
that
my
there are
hand.
some
So
yeah
then
examination.
they started gossiping around me, like to each other.
Oh.
Those kind of things
Oh,
they
no,
did.
so from there are representative from IIT Madras also. You can just meet them directly. At every center there are some representative. Okay.
Oh, okay, okay.
Yeah, so you can directly ask him where is the IR or something. Okay, that I guess. Yeah, representative are there at every center. Okay, many a times I also used to go for some of the center, but yeah, there used to be in Pan India everywhere we have somebody who represent. Okay, so you can meet
Okay,
him directly. So they will be there till the end. Okay, you can ask the invigilator or whoever is there to ask like, is there any representative from IIT Madras? I want to talk. So you can talk to them.
okay, sir. Okay.
Yeah.
Okay, sir. Thank you, sir.
Thanks. Okay. Thanks everyone, and have a
Hello,
good.
sir. I have
Yeah.
some doubt.
Doubt regarding what?
Sir, I have some doubt regarding the like I have qualified the qualified exam, but let's say if I don't join the don't join register for course in this term, then for the next term I have to do some everything from scratch, like from start.
No, no, you can do it from next time also. You can continue. If you have already qualified, yeah, you will be getting one more term. You can do that at that time.
Okay, like if I register for next term, then I don't have to give the qualified exam again.
You don't have to. But you'll
Okay.
have to, you so the way I'm saying is you've already qualified all the courses, right? Four courses, right?
Oh,
So then you can directly enter, like you already got the admission. You can, if you don't want to write maths one this term, you can write the math next term. Okay.
oh.
Right.
Yeah.
He has to do the week 1
And
and week 4, right?
for how many terms it is valid? Like
Like
I
you have to write the quiz paper. Quiz one you'll have to write. But the one I'm saying is you'll have to write everything next time. Matlab, you'll not have to write the, like you have already passed it, you got the admission, but you'll have to write quiz one, quiz two, everything again. That is what I'm saying. But if somebody who didn't pass qualify, right? So for them that will become a qualified. He has to pass. Like if you are getting, let's for example, next term, I'm just saying, but if you are, let's for example, you'll not get it, but I'm saying you got very bad marks, okay? Like less than 40 or so, maybe 20. So if it was qualified, you would not have passed, right? You have to repeat it. But if you have quiz one, 20 marks in quiz one, okay, that's fine. Quiz two, if you got 100 marks, final quiz 100 marks, then you will pass it, right? Are you getting what I'm trying to say?
no, sir. Like
No.
I'm get
Okay. What I'm
confused.
saying is, see, qualified, you have wrote it, you passed it already, all the four courses, but you don't want to continue this term. Next term, you want to
Oh,
continue. So that means
yeah,
you have already passed the qualifier. Next time you
yes.
will come, you will consider it as a, you have already entered the college, you are just writing the quiz. So one quiz, if you are absent also, second and final quiz you can make up and then get overall for more than 40% of marks, and then you'll go to maths 2. But if somebody who has not passed qualified this time and then you want to write it next time, for him, if he are absent, that means he didn't got the admission altogether. Okay. So if you are passing all this time, you got the admission, you can maybe drop it for this term and then continue from next term. That is fine.
And sir, one more thing, like let's say
So
ki I'll
yeah,
complete
and
my
then for other also, if you are getting confused, you can write it to support team. So they are just for those query only. Okay, they will clarify even better than me. Okay, you can just write
okay,
it to support at the study.iitm.ac.in. They are the best person to guide you about. So they know each and every steps, like what could be done, what have been done. Okay. Yeah.
sir, one more thing, like let's say I've completed my foundation and then during foundation and diploma level, I want to take the break of one
You can
term
take.
or
Yeah, you can take a break of one term and then can continue. Okay.
okay,
So that's
like
why it has been said, right? You can cover the whole course in some 6 year or 8 year. Okay, 8 year, I guess. Okay, the 4 year of course you can complete it. So you can in between, if somebody has to take a gap. So this course is very flexible. You can take a gap also, and then you can recontinue. Okay, but you can't be going for 2 3 years and again coming, right? So that doesn't work.
okay, like sir,
Hmm.
I can take, let's say I have to take just one term or two term break, then I can take this.
You can take a break, yeah, and then you can continue like one courses per term or something. So many of the people just take one courses, so that the pace, see, they are also completing the courses also. One courses and all is not that difficult to finish in a term, right?
Yeah, right, sir.
Yeah.
Okay. And sir, one more thing, that in a direct entry through in diploma, there is a
But
okay,
direct
like
also you can take, yeah, there will be some exam that happens, okay? So that exam you have to write it. So that will
so
be a
like
bit difficult one, yeah. So it will be like the full course of maths one, okay? So they can ask you anything, graph theory and all. So that will be a bit difficult, okay? Many other passing percentage of getting admission in that is become direct admission to diploma, okay? That you call this as a so direct admission, if you are getting that, is a bit difficult than getting into qualifiers, because the questions will be a bit tougher, and then the syllabus will be vast too. So and they can ask you anything. Yeah.
sir, I'm
Uh,
confused. Like right now, I'm in my final year of my degree. That whatever I'm pursuing, right now I'm pursuing BCA from my hometown. So, uh, I think next year I got graduated. So what should I do? I either I continue from the foundation batch from now, or I wait and get through the direct entry diploma.
No, if you have already started, you keep on doing it, na? Like keep on doing. So in coming 2 terms, you will be able to finish right everything for the foundation.
Yeah.
Hmm.
And then after foundation, if I want to, let's say I want to take a break of 2 to 3 terms, then nothing will go any wrong. Like I can take that break.
If what? Can you repeat?
Like sir, after completing my foundation, let's say I completed my foundation in May term, like January and May term in 2 terms.
Yeah.
So after that, can I take break of September
Yeah, you
and
can
January?
take break. Yeah, you can take break in between anytime.